Welcome back. Question 6 is about particle theory. So first question is about what is an elementary particle. We remember in our standard model we have 12 elementary particles. What do you mean by elementary particle? It means that it can't be broken down into smaller one. There is a definition. Smallest possible one. So can't be this broken into smaller one, okay, smaller particles. Okay, next one, these the fundamental forces that act on quark. Forces. So first of all, quark are bound by strong force. Okay, quark also have charges, so we also have electrostatic force. Quark also have masses, so we also have gravitational force. So three forces. Sometimes you are afraid which one has the mass. Okay, so these are the most important ones, strong forces. Okay, I think it must have mass for this one, but there's forces here. Why is it? Oh, it's the same. Yeah. So it's confused. So at least the first one first. Okay, strong force and electrostatic force, and then gravitational force. Okay, all the quarks have this force between them. Okay, next one. Okay, three. Okay. Stay and explain which fundamental interaction is responsible for this decay. Okay, so look at the decay. Although at first it is strange, if you don't know how to do it, okay, a little bit confusing, but this how the quark you understand. Okay, so the change is from UDS to UUD plus U body. So anything not conserved, yes, the string particle disappear. The string chord disappears. So strangeness drop by increases from -1 to 0. Yeah, remember to look at the data booklet. Strangeness of a string chord is -1. So you can say strangeness increases from -1 to 0. As strangeness is conserved, but just the difference is one. It is allowed because it is weak interaction. Yeah, only in weak interaction do the strangeness can be not conserved. Okay, good. B1, by reference to the concept of binding energy, explain why the total mass of the nucleons is greater than the mass of the nucleus. So first of all, you remember what's binding energy. Binding energy is the energy released when nucleus is formed. It's the energy released, just like the bond energy in chemistry. Okay, when a nucleus is formed, so the nucleus has a lower energy, and the combined energy of the nucleon is larger. So the total energy of nucleons is larger. But why larger energy is a larger mass? Because E equals mc squared. Yeah, think of Einstein. Okay, larger energy means larger mass. So total mass also larger. You need to write it down step by step. Okay, don't jump the step. Okay, write out in details. Okay. So the total mass of nucleons is larger. Next, then we want you to calculate the first change back to the pen. Okay. Okay. Determine the energy released in the decay. Look, it is per nucleon binding energy. So look here, everyone has binding energy. Better energy means lower of the energy. So look here, it has a decay. So this one should have a lower energy, right? This one has a higher energy. So on the other hand, for the binding energy, total binding energy, this one should be higher because it is in a lower energy state. Right? This is the energy. So Tx should have a lower binding energy total. Okay, so about the energy we need should be this binding energy minus this one. Okay, larger one minus smaller one. So make sure you copy it right. Okay, ROA 7.6799917 times 224, and then helium 7.07315 times 4, and then minus the binding energy of Tx 7.645074 times 228. A lot of my students make mistake in copying, so make sure check it. Okay, and then calculation time. Straightforward, right? So you got it. The difference is 5.52 MeV. Next question is stranger. It is observed that sometimes the alpha decay is accomplished by gamma wave emission. Gamma wave? Why alpha decay is gamma decay? Suggest an explanation for this observation. Look here. Ra is created, right? Ra has a different combination of neutron and proton. Maybe it is in an excited state, nuclear excited state. So it will release its energy by gamma decay. So you can say Ra produced has a different combination, orientation, or whatever. Okay, different numbers of proton and neutron. So maybe it is in an nuclear excited state. So it may emit gamma radiation to release the energy. So it may be in a star state, right? Nuclear excited state. So gamma radiation will be emitted by it. You got it? This part is hard, I must say. So this part is the part that makes you 7 or 6, okay? So be innovative, be creative, try to link up different parts of physics when you do the IB question. I'm sure after more practice, you can do it, okay? See you for question 7. Bye.